All right. It's time for corresponding parts of congruent triangles are congruent. Yes. Okay, we already know this. We actually started off our unit with this knowledge. When we said that two triangles were congruent, we named their corresponding parts and we wrote congruent statements. So we're just going to see today how we use that in proof. So Cpctc just stands for corresponding parts of congruent triangles are congruent because we don't want to write all of that. Like no one wants to write all that in a line. So this is another abbreviation that we get to use in our proofs. Yes. Okay. So you can only use it in a proof after you have proven that your two triangles are congruent, because before you've proved your triangles are congruent, you can't say that the corresponding parts are congruent. So remember, our other shortcuts, side, 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 angle, 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 side, and hypotenuse leg use the corresponding parts to prove that triangles are in fact congruent. And then at the end, we will use corresponding parts of congruent triangles to say, okay, well, now that we know our triangles are congruent, we can say that these parts that we didn't have any information about, they are also congruent. So that's how we will use this today. So let's start off with some non-proof examples. Okay, so it says that points A and B are on the edges of a ravine. So you can't just like walk from A to B with a measuring tape and measure the distance because it's off a cliff. So that's the premise of this one. All right, well, we have some information. We know that 15 miles is congruent to 15 miles, and we know that 10 miles is congruent to 10 miles. We also have, by the vertical angles theorem, that this angle is congruent to that one. Thank you, VAT, vertical angles theorem. So what I see here is that we have two congruent triangles using the shortcut side, angle, side. So I've shown that they're congruent using side, angle, side. So now I can say, oh, well, if this last side is 18, so must side AB be 18. So I can say AB is 18. This AB should have a line over it. So if it doesn't have it, if I forgot to add it at the end, will you add that, please? The length of AB this is the measure of AB, but we're talking about the segment AB there. So that's how we would use it. So AB is 18 by corresponding parts of congruent triangles are congruent. So it's only after we've used side, angle, side to say the triangles are congruent that we can use that. All right, let's look at another example. All right, here we have a landscape architect setting up the triangles shown in the figure to find the distance, JK, across a pond. Okay, so he's not going to walk through the pond with a measuring tape. So we want to be able to find another way to get that distance. So we know that 19 is congruent to 19. We know that 30 is congruent to 30. Okay, we've got a pair of vertical angles. Thank you, vertical angle theorem. Then we can again use side, angle, side to prove that these triangles are congruent. And finally, we can say that the side MN is congruent to the side JK. So we can find the measure of JK is 41 feet. By using corresponding parts of congruent triangles are congruent. Ta-da! That's it. All right, so now we're going to do some actual proofs. So here we have one to complete. It's a flow proof. They told us that YW bisects XZ. I see that here at the very tippy top, so I'm just going to write in given for that one. Oh. Okay. Next. What else was given to us? Well, we know that XY, the segment, is congruent to segment YZ. Okay, that was given to us. So let's mark down all this given information. So XY is congruent to YZ. And we had that YW bisects XZ. Okay, so this one is congruent to that one. So we didn't write that in our proof yet, so let's put that in our proof. That came as a result of this being a bisector. Okay, so the definition of a bisector tells us that XW, segment XW, is congruent to segment ZW. And I'm making sure that I've got the right order because XW, ZW. Okay. Now, we've got two sides congruent. We either need another side or an angle. Now, what I see here is a shared side. I see that they're both sharing side YW. And here they're saying that YW is congruent to itself. Okay, that is because of the reflexive property of congruence. Okay, so here I have three pairs of congruent sides. So these triangles are congruent by side, 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 side. Now, what we have to prove is that these two angles are congruent. So now that I've got two congruent triangles, I know that all of their corresponding parts have to be congruent. So what I want is to show that XYW, the angle XYW, boop, boop, is congruent to angle ZYW, boop, boop, and it is because those are corresponding parts. So I'm going to say corresponding parts of congruent triangles are congruent, and I'm done. The smiley face is optional. That wasn't one of Euclid's things he did. All right, we've got two more to do, and then we are done with this notes. This is our last set of notes for Unit 3. And we're just going to review. Okay. So this time, they want us to prove that a pair of sides are congruent. So we want PQ congruent to PS. So that is this one and this one, oops, that we want to prove are congruent. So first we have to prove the triangles are congruent, and then we can say that their corresponding parts are congruent. So this says that PR bisects angle QPS and angle QRS, and that was our given statement. So I'm just going to write given here. Okay. So that gives me a couple of conclusions. Okay, I know that if it's chopping these angles in half, it's going to give me pairs of congruent baby angles. Okay, that's how baby angles are made. So QPS got chopped in half and made two baby angles. And QRS got chopped in half and made two baby angles. So I'm going to say QRP. Huh. All right, well, I don't agree with how this is written, guys. Okay, so I didn't catch this when I was doing all my edits, but we're going to change this. We're going to get rid of this line here. Boop, 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 boop. And we are going to say that this one goes over here. Doop, 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 doop. Because the fact that this is a bisector makes these angles congruent to each other. I don't know why those aren't connected in this proof. I feel like that's a mistake. So we're going to fix it because I'm the one doing the notes. Okay, so that we know that it's these little baby angles were made congruent to each other because of this bisector. That's the definition of a bisector that did that. Definition of angle bisector. Okay, so I have two pairs of congruent angles. I don't want another pair of congruent angles because then I would just have angle, 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 and that does not work for congruence. That just makes similar triangles, okay, because the triangles can be different sizes and have the same angles. So I need a side. I need a side. So my side is going to be this shared side. They both have this side PR. Okay, let's look at the order. I think it's in the same order. PQ, yeah, it's in the same order. So we can just say PR is congruent to itself. PR is congruent to PR because of the reflexive property of congruence. Boop. Now I've got angles, an included side, and another set of angles. So I have angle, side, angle. Angle, side, angle. And angle, side, angle tells me that these triangles are congruent. So I know that PQR, so triangle PQR is congruent to triangle PSR. Oops, I forgot the triangle symbol. PSR. Okay, by angle, side, angle. And now that I have congruent triangles, I can say that their corresponding parts are congruent, which is what I really wanted this whole time. So I can say that PQ is congruent to PS because of corresponding parts of congruent triangles being congruent. Ta-da! All right, let's do another one. Here we go. Here we go. All right, they're telling us that segment NO is parallel to segment MP. Okay, they're also telling us that angle N is congruent to angle P. And we have to prove that segment MN is congruent to segment OP. Okay, that's the target. I can only say that those parts are congruent if I'm able to prove those triangles are congruent. So first I have to prove the triangle's congruent, then I can say their corresponding parts are congruent. So I am going to redraw this picture with the parallel lines in the transversal and without the extra sides so we can see it. These are my parallel lines. They're very beautiful. Okay, here's point N, just so that you can kind of see what's going on. Here's O. Here's point M. Oh, shoot, I did that badly. Hold on, I'm going to fix it. I'm going to fix it. Here's N. Here's O. Here's M. And here's P. Okay, so now I need my hot pink transversal. Why is it hot pink? Because I'm the one drawing it. Okay. Now, all I did was redraw this picture with the parallel lines extended, okay? And I got rid of the pesky sides N, M, and OP because they were kind of messing with my world. Now I can see very clearly that in the interior of my parallel lines, I have some angle pairs that are going to be congruent. My angle pairs that are congruent are him, him, and him. Do you see how those are in my triangles? It's this guy and this guy. But it's kind of easier to see without the other sides of the quadrilateral gucking it up. Okay? So if you have to do this, go ahead and do it. This is how I have to do it. So, back to this picture. I have alternate interior angles congruent because of those parallel lines. So that needs to be in my proof. Okay? So let's start with the givens. I have angle N congruent to angle P, and that was given. I have segment NO is parallel. Why did I write it over there? Segment NO is parallel to segment MP. That was given. Now, because of those parallel lines, I have these alternate interior angles that are congruent. So this set of parallel lines gives me angle OMP. Angle OMP is congruent to angle MON. Okay, and that is because the alternate interior angles theorem. Okay, now I have dun, 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 a beautiful, lovely shared side, which is congruent to itself by the reflexive property of congruence. So let's think about this. It'll be triangle MNO, MON, ONP. Okay, look at this. Do you see how for the segment MO, like the order is different? Okay, so just be careful of the order. We want segment OM is congruent to segment MO. And that is because of our reflexive property of congruence. All right, so it looks to me like I have angle, angle, side. Angle, angle, side. Angle, angle, side tells me that triangle OMP is congruent to triangle MON. Now that I've got my triangles congruent, I know that all of their corresponding parts are congruent, not just the ones that I was able to figure out before. So that tells me that segment OP, oh my gosh, my brain just died. OP is congruent to segment MN. Oh, here, they wanted it in the other order. We'll do it in the other order. We'll make them happy. We'll make them happy. Ah, what just happened? Okay, so segment MN is congruent to segment OP. And that is because the corresponding parts of congruent triangles are congruent. That's all she wrote. Thank you for joining me for another installment of your geometry notes.